I hope you enjoyed that exercise. The next topic that we'll be looking at are interactions and how we can receive input from the user in order to either update the styles or the layout of our plots. Before we look at some of the interaction methods, I just want to mention data annotations. In Plotly, we can create annotations that are linked to individual data points to help clarify particular pieces of data. If we look at the JavaScript for this example, we can see that the annotations get added in the layout object rather than in the data itself. These annotations get added as an array full of objects where each object represents one annotation on the plot. Inside the object, you've got a few properties that you can use to style and change the position of your annotations. Firstly, you need the X and Y values, which need to be exactly the same as one of the points in your data set. You've also got the text property, which is where you set the annotation text itself, and the show arrow property for showing the line with an endpoint directly on that data point. The arrowhead property is a number between 0 and 8, which allows you to set different styles for that endpoint on the line. I'll let you guys experiment with the different styles of arrowheads that you can use. The last values that we include are the offset for the annotation based on that data point. So here we are applying an X offset of 0 and a Y offset of -40, which is placing the annotation above the data point. If we made that a positive Y value, it would be below the data point, and we could move the annotation to the left or the right, depending on an offset that we give to the AX property. Annotations will help call out specific points of data, and you can use similar interaction methods that we'll be learning today in order to conditionally show and hide these annotations as well. The first interaction method that I'll walk you through are hover labels. Hover labels allow us to display extra information when a specific data point is hovered on. In this case, we're showing the X and Y values for that point. You use the hover info property in order to choose what data gets displayed when you hover over a point. You can set any combination of the X, Y, and Z axes using plus operators to join them all together, or you can choose the all if you want the X, Y, and Z plus any additional text data, or the none value if you don't want to display anything on hover at all. Note that the value for hover info gets set inside each individual data object. So we can actually choose at a trace level which properties we want to display when the user hovers over them. In terms of styling the hover labels, we can set those properties inside the layout object. So we've got the hover label object, and that has some sub-properties, including the BG color, the background color, which I've commented out in this case to show you that by default, the color will be the same color as the individual trace. We can also set the border color, and that will simultaneously set the text color for us if you just use that property. In this case, I've set the color to green, which is pretty terrible, and you would likely never do this in a real visualization, but at least it shows you that that is changing the default border color from black. One last thing that I'll mention is the hover format property, which lives within the X-axis object inside the layout object. And there's a couple of different ways that we can format the data that will then be displayed in the hover tooltip. One way we can do this is using the point notation, so decimal point followed by the number of figures you want to have and then the type of figures. So in this case, F for figures will just show us the individual 2 decimal points after our main value. This is contrasted with .2r for the hover format value, which rounds to the nearest two significant values. And we'll see if we can find an example of this in the plot. So here in this case, we can see that the value for the x-axis is negative 0.96, and then the value for the y-axis is 0.033. So there's three figures that are being displayed after the decimal point there, because one of them is 0, so we're showing the two significant values after that 0. If you want to include more information in your hover labels, Plotly has a feature called hover templates that you can use to customize the text and content that's getting displayed using HTML syntax. In this example depicting the risk of job automation in lower paying jobs, when we hover over an individual data point, we see not only the job itself, but we also see the income, the probability of automation, and the number of people employed in that given job. So this is information that is mostly available on the chart anyway. The automation probability is coming from the x-axis, the income is coming from the y-axis, and the number of people employed is relatively shown using the size of the marker. What isn't shown at all anywhere on the graph is the name of the job. And so that's some extra information that's been added in via a hover template. We also are able to format our data using things like labels, such as this text for income, before showing the final value, which is the actual amount. Coming back to our Australian beer prices map, we can see that I've used hover templates in order to display the city, as well as the price of beers and the longitude and latitude where that price was recorded. We can hover on each of the different data points to see that this is updated and dynamically set for that specific point. In the JavaScript, we can see the hover template property, which lives within the data object, and we use string concatenation to combine all of the HTML structure that we want to use in that hover label. We can see that I've used a variable here using a percentage sign followed by curly braces or mustache brackets to show the custom data value inside our city text. This custom data property is being set above in the data object as well, using the CSV rows from the city column. This is a property that you have available to store extra information in, and you can do it using this kind of method. In the second line, we're using the text property, which brings in the value of the text property from the data object as well. And then we're adding some extra formatting around that using some bold tags and some line breaks afterwards. Similarly, we've got the longitude and latitude using the values from the properties, but also getting some extra formatting using the 0.2f notation that we saw before. This is separated from the property name using a colon, so make sure you get that syntax right if you want to use this kind of formatting. Lastly, the extra tags are used to hide the trace number that normally gets displayed just on the right-hand side of the hover label. This might be some functionality that you want, but in many cases, you want to fully overwrite that, which you can do by creating the extra tags and leaving them blank. The next type of interaction that we can do using Plotly are buttons. And we can see in this particular example, we've got two buttons at the top where one is already clicked. So that's being indicated by the color change. And that's representing the current state of our visualization, which is a 3D topographic surface map. And then the second button, which will light up when we hover over it to know that it can be interacted with, is to change the layout of our graph to be a heat map. We can then toggle back and forward between these two states. In JavaScript, the way that we add buttons to our plots is using the Update Menus property within the layout. This Update Menus property has just been set using a variable that we've created just to make it a little bit easier to keep track of our different menus. In this case, we have an array because it's possible to make multiple menus on the same plot. And for our example, we just have a single object inside that array at the moment with the buttons property representing the type of menu that we want. Inside this buttons property is another array where each of the objects inside represents one button, and the properties for that object include the args, so the arguments for that particular button, the label, which is the text that we can see, and the method. This is what Plotly will do when the button is clicked. So we are changing the style of our plot. There's other things that you can change, including the layout and the data itself. But in this case, the method that we're calling is restyling our data by changing the type of graph to a surface or a heat map, depending on which button is pressed. The last properties are used to set the location and position of those buttons in the plot. This next example is showing us how we can use HTML drop-down select elements in order for the user to be able to conditionally filter some of the data that they're seeing on the plot. This is Alex's regression example from the other week, and this time we're using the drop-down select menu to select the country that we want to display the mortality data for, including our regression prediction. So we can see that when we change the country in our select menu, the data will update and Plotly will redraw that graph. This will keep working no matter how many elements we have in our list, and this list is being dynamically set from our data itself. So let's take a look at the JavaScript to see how this has changed in order to have the functionality of this drop-down menu. At the top, we can see that we've set up some variables. So we have a variable called CSV data, which is currently unassigned. I'll talk about this one in a little while. We've then got a variable for all country names, as well as a list of countries array that is currently empty. Lastly, we have an element selector, which is storing a reference to the country data class element in our HTML. And we can see if we jump into the HTML that this is the select element. So we're using that select element to then do a few more things later on in our code. So we want to have a reference to that element to make it a bit easier. Next up, we are running the CSV Import Function, this time using a link to a GitHub file, but you could still use the local file to do this if you wanted to develop it on your own machine. And then we've got the callback function for that CSV import. In the callback function, we're passing in the parameter for the resulting processed array of our results from the CSV import. And this is set to the value for our CSV data variable. So this is why I needed to establish that variable outside the scope of this function so that we could globally access it both in the CSV import, but also later on where we're making our plots and updating them based on the user's input. Inside the CSV processing file, we're also unpacking the country column and creating the all country names variable using the different row values thanks to the CSV import. After that, we will run a for loop, and this is going to take all of those country names and filter them down to see if that country already exists in the array. And that's what this line is doing here. It's saying that if the list of countries already includes the current country based on our for loop, then we would like to add that to the array called list of countries. After that, we call the assign options function, which passes in the input parameters of the new array of filtered countries. and the country selector element that we established at the start. The reason that we needed to filter out those countries is because in our data set, we had multiple rows with the same country. This time, we need to ensure that the data is only unique countries because these are the options that are appearing in the selection element. So this function assign options is just another for loop to loop through the array and create an individual DOM element, in this case an option element, and add the text using the value from the array before appending that to our selector. After that, we call the makePlot function using the CSV data, which is now our global variable, as well as passing in a default country just to get us started. In this case, we've just used Afghanistan, the string. So that takes us from our data and creates all of the HTML elements. Now we want to go the other way and use the HTML selection to then suggest which data we should be displaying. We do this using an event listener on the select element itself, and we're listening out for the change event. So anytime the user changes their selection. At this point, we're going to run the update country when that happens, and then that will just simply call the makePlot function again. So it will remake that plot using the exact same data set, but this time passing in the current value of the country selector. In terms of the makePlot function, we really didn't change much to get this working. All I had to do was add the current country as another input parameter to the function, and then use that input parameter to filter through the data. All of the other regression and prediction stuff still works exactly the same, and it will just automatically be updated based on the input of the user. So those are a few of the interaction methods that we can use both within Plotly and also just through our typical HTML DOM manipulation and JavaScript event listening. The next thing we're going to be looking at is animations. So we won't do an exercise for interactions just yet, and then at the end we'll combine both interactions and animations into a plot of your own. I'll see you in the next video.